Good day, students. Today we are learning about the synchronization in operating system. See in the first one, the synchronization to synchronization. So the introduction to synchronization is an critical concept in operating systems. So definitely we should understand what is synchronization in this concept. We should understand it. Okay. Then only we can easily identify the remaining process. See here, the ensure that multiple processors or threads can access shared resources for data without a conflict. Okay. Then after go for the next one, synchronization mechanisms prevent race condition and ensure data integrity. So see here, see in the increasing concurrency in the picture, one object shared among threads. See in the picture, W means write mode and R means read mode. So here read mode and write modes are there. See what happens. Each thread is either a read or a write. Okay, so he may be the reader or may be the writer. Okay, see in that the readers only read the data. He can't modify the data, but the writers can read and modify the data. See, these are the different concurrency consequences. Okay, then I have to go for the next one. Need for synchronization. So what is the need of synchronization? Without the synchronization, the concurrent access to shared resources can lead to inconsistent or the incorrect results. Maybe at a time A and B will changes, but sometimes we will get confusion state. We call it as an inconsistent data. Okay, so race condition occur when multiple process or threads access shared data simultaneously. Okay, so that's why we need the synchronized tool necessary to prevent a race condition and maintain a data integrity. See the next one. Mutex locks. See in the picture, the locked and unlocked. We call it as a user and a locked system. Okay. See in the mutex locks are synchronization primitives used to ensure exclusive access to shared resources. So here we can share the resources, but sometimes we get confusion in sharing resources. Why? The mutex allows only one person or one process or thread or to acquire the lock at a time. So no other party can access it, or no other process can access it. That's why we doesn't get any confusion. Seeing that the process or a thread attempts to acquire a locked mutex, it will be blocked until the lock is released. When the lock will release means after completion of the process. Okay, then after go for the next one. Semaphores. One of the important topic here is semaphores. See in semaphores are synchronized objects that restrict access to shared resources. See the word shared resources with a counter. See how the counter can be incremented or decremented by processor or threads to control access. We call it as two key variables like incremental or decremental to control the process. Okay, process access. Okay. See the semaphores can be used for the signaling or the mutex exclusion between multiple processes. See in the picture, the semaphores is an object that consists of a counter or wait list of a process and two methods, call it as a functions or a signal wait and a signal wait, or a signal or a wait signal. Okay, it's a wait, both. See what happens in the wait and the signal. See in the method of signal, the counter, and see the method of waiting list. We call it as a waiting list. After it will get the chance. Okay, see we call it as a semaphores. In semaphores we use the two keywords signal and wait. We count it as a counter as a signal and waiting it as a wait. Okay, these are needs for the semaphores to synchronize. Then after go for the next one. Deadlocks. One of the most important concept in synchronize is the deadlock. So why the deadlock will occur? See after you will get this. See here deadlock is a state where two or more processes are unable to proceed because each is waiting for another two resources. So it waiting for the resources, other one will lock it. Okay, see how The deadlock can occur if the synchronized mechanism are not properly implemented. So we need a synchronization definitely. Okay. Then after, the techniques such as deadlock detection, prevent or avoid can be used to handle the deadlocks. How we can handle the deadlocks? We can learn it. Okay. See in the picture, see the resources A is processing and it locked. So some resources locked. Okay. So the next resources here we have a 2, thread 1 and thread 2. The deadlock occurred when the thread 2 is waiting. And sometimes maybe thread 2 is locked and thread 1 is waiting. We call it as a deadlock. So we occur deadlocks in these some situations. Okay, go for the next one. Condition variables. What is a condition variables? Why we need it? In condition variables are synchronization primitives used to coordinate the execution of threads. Okay, see, they allow threads to temporarily block until a specific condition is met. Condition variables are often used in conjunction with the mutex locks to implement the synchronization. See in that the introduction condition variables, first one, see the correctness requirements for bounded buffer producer or consumer problems. See, you know very well about the procedure consumer problems. Okay, so only one thread manipulates the buffer at any time, and a mutual exclusion, we call it as a mutual exclusion. Okay, see the next one. Consumer must wait for the procedure when the buffer is empty. Okay, so you should wait after getting the empty, we will get it. Okay, so scheduling and synchronization constraint here occurs. Okay, then after go for the next one, last one. Procedure must wait for the consumer when the buffer is full. So here the scheduling synchronization constraints. So the three states will occur. See the solution. The solutions will be condition variables. We take a condition variables as a solution. See how the abstract that supports a conditional synchronization. See, an abstract that supports a conditional synchronization. First one. See the next one. Condition variables are associated with a monitor log. See the next point. A conditional variables are associated with a monitor log. We call it as a monitor log. See the next one. Enables threads to wait inside a critical section for releasing the monitor log. See, these are the solutions to occur after occurring the problem we can manage. Okay, see the next one. Our readers and writers problem. In the readers and writers problem, first to see the picture. One writer, one reader, or scenario 2. See here. So 0 and mutex 1 or readers 1. Okay. See here, writer and reader both are there, and wait mutex, and write here, and signal mutex. Here also readers in the readers, wait mutex and readers plus plus, and if reader equal to 1, the wait mutex, signal mutex or read mutex. This is the process how they are coordinating with each. See, wait mutex and readers minus minus. Okay, it completes the task that we get the minus minus. If reader is equal to 0, then signal we are mutex. Okay, WR mutex. Read and write mode. See, the read mode, write mode, and read and write mode. So signal mutex. See, after getting this, see in the picture. The reader-writer problem is in a classical synchronization. We call it as a classical synchronization, and it involves multiple threads accessing a shared resources with the different levels of concurrency allowed for readers and writers. So maybe it is in a classical program. The classical means it is a first level, and in the time of concurrency, so many readers and writers will use that at a time. Okay, then we get here thread access shared resources. Where synchronization techniques such as read-write locks or semaphores can be used to solve this problem. Okay, so they have to go for the next one. See the procedure consumer problem. See in the procedure consumer problem, bounded buffer size n and access entry 0 to n minus 1 and wrapped around to 0 again, and procedure process writes data to buffer, or the must not write more than n items because we size the more than consumer A. Okay, then after go for the next one, consumer processor reads data from the buffer. See, here first we are giving the data, next we are getting the data. This is a concept we called as inputting the data and outputting the data. How we are measuring it? So n size. See the conditions. The procedure consumer problem is another common synchronized problem. It involves a multiple threads where one process data and another consumes it from a shared buffer. Okay. Thereafter, a synchronized mechanism like semaphores or mutex locks can be used to solve this problem. So easily we can implement this by using these two keywords. Okay. Then after go for the next one. Synchronization in distributed systems. You know very well about what is distributed systems. We learned it in the types of operating systems. Okay. See now, the synchronized is also important in distributed systems. How? Where multi-nodes communicate and coordinate with each other. Then distributed synchronized algorithms ensures consistency and avoid conflicts in shared data or resources. And after, techniques like distributed locks or timestamps can be used for synchronization in synchronized distributed systems. Okay. Then after go for the next one. Conclusion. See in the conclusion, first see the synchronized overview. See in the synchronized overview, the characteristics are cooperative process synchronization. Okay, how they are operating with each other. Okay, see we call it as in a read mode or write mode. Okay. Then after go for the next one, selections, how they are selecting the critical section, how they are facing the critical section. Then after some mechanisms for dealing with the critical section like mutex, semaphores and monitoring. Okay. See the other topics like Peterson solution is one of the best example for this synchronization, and classical problems like dining philosopher and boundar buffer problems are procedure and consumer problems are the few examples how we can rectify these are synchronized. Okay. See now the conclusion. Synchronized is a fundamental concept in operating systems, ensuring a concurrent access in the time of concurrent access to share the resources in managing correctly. Okay. Then after go the next one, the various synchronization mechanisms like mutex locks, semaphores are condition variables, and synchronization algorithms are used to prevent race conditions and maintain data integrity. So the synchronization is without the synchronizer, without the conclusion of the synchronization fundamental concept, we can't access the process in proper way, in multiple level access. Okay. Thank you.